So in this last segment, we're going to look at how to predict the charges of the gainers of electrons, or the negative ions, and then we're going to see what happens when we put these ions together, how we can look at that to form compounds. So here are the gainers then. If we're looking at group 15, find that on the periodic table, those things tend to gain 3 electrons and become -3 anions. So we can follow the pattern here. 16 tends to gain 2 electrons and become -2, and 17 tends to gain 1 and become -1. An interesting thing to consider is what happens to group 18 if you kind of follow the pattern. If we went from -3 to -2 to -1, the next number would be 0. And so group 18, the noble gases, tend to not form ions at all. All right, so what happens when we put this all together? We take the losers and the gainers and we see what we can do with them. So when would an atom lose or gain electrons? I told you earlier in one of the videos that this doesn't just happen spontaneously. Something has to happen for an atom to gain or lose an electrons. So I've also already mentioned that metals tend to lose electrons, and nonmetals tend to gain electrons. So if we have the process of a metal and a nonmetal that are put together under the right conditions, then the metal will tend to lose its electron to the nonmetal. So the metal becomes the ion, the positive ion, and the nonmetal becomes the negative ion. And we call that an ionic compound because it consists of a metal ion and a nonmetal ion that are now just attracted to each other because opposites attract. Okay, so opposites attract. These two ions are attracted to each other. And so how do we know what the formula for the compound is? Well, how do we know how many of each there's going to be? So what would the charge of a compound be? You know, nature doesn't like separate charges. So the charge of a compound has got to be 0. So that means that the number of positives and negatives have to be exactly balanced out. So let's consider this. Let's do some practice then. If we have a potassium ion and a bromide ion, now if we go to your periodic table and have a look at what's going on in your periodic table, potassium is in group number 1. It's a +1 ion. Bromide is group 17. It's a -1 ion. So the pluses and minuses would balance out if we just put potassium together with bromide. So the formula for this would be just KBr. Now, this is preview of what the next chapter is going to be, so we're just going to kind of hit the highlights here. And I'm going to give you a few to practice on here. What happens if we have calcium and fluoride ions, or rubidium ion and oxide ion, barium ion or nitride ion? So why don't you put this on pause and try to work those out, and when you come back, we will look at the answers. All right, so answers to this. So potassium and bromide, as we said, is potassium bromide. Calcium and fluoride. Calcium is a 2+ in group number 2. Fluorine is in group 17. It's -1, so we have to have 2 fluorines to balance that out. Rubidium oxide, Rb2O, because rubidium's +1 and oxygen is -2. We have to have 2 pluses to balance that out. And finally, this one's a little trickier, I guess, because we've got barium, which is +2, and nitride ion, which is -3. And so we're going to need 3 bariums and 2 nitrogens to make those all balance out. Whenever I see this, I always think, let's get to 6, because barium is +2 and nitrogen is -3. So 3 bariums will give you 6, +6, and 2 nitrogens will give you, or 2 nitrides will give you -6. Okay, so that's it for changing atoms to ions.